we're going to be talking about what a designated router is, when a designated router is required, how designated routers function, as well as some default settings, how you can specify what router becomes a designated router, as well as some troubleshooting tips. In OSPF, a designated router is the router that all the other routers have to get their updates from. Let's say this router right here is a designated router. What that means is every other router, router A, B, C, and D, all the other routers would get their updates directly from the designated router. They would not exchange information with each other. Now, designated routers are needed in certain environments to cut down on the amount of traffic. In a LAN environment, it's an automatic requirement to have a designated router. Sometimes a LAN environment like this might be the center backbone of your routed network. So in that LAN environment, you'd like to cut down on traffic as much as possible. If you did not have a designated router, A would have to exchange info with C, and D, and B. C would also have to exchange with B and D and the DR, even though it wouldn't be called the DR, it may be called router E. D, B, B, you get the idea. All this excess traffic can slow down your network, and it's unnecessary. So that's why that designated router is there, is to get rid of that excess traffic. So how does a router become the designated router? First thing happens when the router is turned on for OSPF and it's going to be communicated on this interface. Let's say this interface is E0, and all the routers have one of these E0 interfaces. The router, or the OSPF process I should say, recognizes this as a LAN interface. So since it's a LAN interface, OSPF designated router is required. So the process of OSPF, when it sends its hellos out, is to elect a designated router. Everybody sends these hello packets out. And in the hello packet is what's called a priority number. The priority determines the designated router. The default priority is the number 1. So if every router in here had a default priority of 1 that I have in there, I don't know why that 1 is blue. It doesn't need to be. So if everybody had the default priority of 1, the color does not matter. So that 1 doesn't matter that it's blue. So if they all have that default priority of 1, they're all going to match. So it comes down to the router ID. The router ID is used when the priority number matches. So then it comes down to the router ID. How do the routers get the router ID? I talked about that in a previous slide, but basically it's an IP address, the highest IP address on an up and up interface. So this guy's IP might be 192.168.1.254. Everybody else would have a lower IP address, 240, 230. Whatever the case may be, everybody else has a lower IP address. This guy becomes the designated router. And what that means is all the other routers are going to exchange topology information directly with him. And how that happens is, instead of multicasting their information out to the typical multicast address, OSPF uses a multicast address to send the routing updates and routing information out. They multicast to 224.0.0.5. That's the IP address they use to send their information out. And normally all routers would be listening to that IP address. Instead, when they're not the designated router, they use the IP address of 224.0.0.6, and the designated router is the only one that's going to get that information. That's a little bit of a lie. There's also what's called a backup designated router, BDR. Since he has the second highest IP, it's likely that he'll be elected as the backup designated router, and he will also listen to all of that update information that's multicasted at 224.0.0.6 address. But he does not reply. He keeps his mouth shut. He won't talk back. This is the only guy that's going to reply and send information. So they all update with him. He's happy. They all update with the designated router, and he can talk back. When he talks back, he sends the information back to 224.0.0.5. So if there's a change on A, he multicasts it out to the designated router, and then the designated router multicasts it back to all the other routers. So everybody gets updated. If something happens in this designated router, he keeps sending those hellos out and tell everybody he's still the designated router. If something happens to him, the backup designated router has been listening to all the information and building that topology database and everything, keeping it all up to date. He will take over and start broadcasting out if for some reason this designated router goes bye-bye. For a quick recap on that, all of the routers recognize that they have LAN interfaces which require a designated router. So what they do is they send their hellos out with the purpose of electing the designated router. And they all want to be the designated router because they get the information first. If all the priority numbers match, which one is the default priority. If you wanted to, and you wanted to make sure that one router couldn't be the designated router, you can give him priority of 0, and that means he can never be a designated router. Or if you wanted a particular router like this guy to be the designated router, you could just give him a higher priority. You don't have to go really high, just the number 2 is higher than all the other routers, and you'd know he would be the designated router. If you had a router that might be more powerful than the other routers or less overhead on it, you could elect that router as a designated router. So they all look at their priority numbers, and when they compare them, the one with the highest priority wins. If they all match, then the router with the highest router ID wins, and he becomes the designated router. The second highest router would become the backup designated router. So what happens now is all of the other routers multicast their information out to multicast address 224.0.0.6. He gets the information, processes it, and then sends it all back out to multicast address 224.0.0.5. Some interfaces don't require a designated router, like a point-to-point. So when we have a point-to-point, there's router A, router B here. They're just going to exchange information with each other. There's not a bunch of excess traffic involved in that environment, so a designated router is not needed in a point-to-point environment. Frame relay may need a designated router, depending on the way it's set up. So in that frame relay environment, there's a couple different ways it can be configured. Some ways need a designated router, other ways would not need a designated router. If you had a frame relay topology set up where it was a full mesh environment, so all the routers could talk to each other. So each router has a direct connection to every other router. This is an environment where you would need a designated router. So this guy right here might become the designated router. And again, he'd be in charge of sending the updates and receiving the updates from all the other routers. Another router might become the backup designated router. If it's not a full mesh and you have multiple point-to-point connections in frame relay, so everybody routes through this one core router right here, this central router, they all have a direct connection with him, there would be no need for a designated router because it's simply multiple point-to-point links. So if it's multiple point-to-point links, you would not have a designated router. There is a command called IP OSPF Network, and that command, and then the network type, that command allows you to specify the type of interface it is. Certain interfaces, again, like a LAN interface, automatically going to be specified. But IP OSPF network and then the type of interface, and there's 5 options here, would allow you to go in and specify what type of interface it is and whether or not a designated router would be required. Not something you're going to have to do all the time, but again, something that you should be aware of. I've got my simulator loaded up, and how I've configured my simulator is I've got 3 routers connected through a center switch, and the IP addresses are all 192.168.1.0 addresses. Palestra 1 has a .1 address, Palestra 2 has a .2 address, Palestra 3 has a .3 address. I've configured OSPF, and I have not changed the priorities. All of the priorities are 1. So based on that information, the router with the highest router ID should become the designated router. Again, that's the one that everybody's going to exchange their information with. They will not exchange information with each other. So this guy becomes the designated router. Now typically, the router with the second highest router ID would become the backup designated router. So Palestra 2 should be the backup designated router. This guy that is out of luck is called the drother, non-backup designated router. DR other. Drother. You'll see that term. So let's go in and take a look at the simulator and see how we can view that information. So I'm on Palestra 2, and what I can do to check this out is I can go show IP OSPF Interface, and it'll show me the information for the OSPF interfaces. It shows me right here that Ethernet is up, line protocol is up. Here it shows me my IP address. It's a part of area 0. The router ID, network type, drother, meaning non-designated router, DR other. Priority level is 1. Designated router ID is 192.168.1.3. Interface address 192.168.1.2. Here's all my hello and dead interval information. Again, it shows me here designated router and 192.168.1.1. He's the one that's not a part of anything. Now, if we go to Palestra 3 and do the same thing, show IP OSPF interface, we can see here that 2, and it actually should have shown up on 2 as the backup designated router. Again, this is a simulator, a little funky sometimes, but it works. We can see 3, 192.168.3, part of area 0. He becomes the DR, network type, designated router. His state, again, designated router, priorities 1. Shows the backup designated router here as a router with the second highest IP address, 192.168.1.2. Hello, dead interval information as well, and again, the neighbor account. I can also do the show IP OSPF Neighbor command and get information that way. But it's not going to show me the full information. It's just going to show me the state. So it has a full state, and what's showing me here is the addresses of the router that it has a full state with, meaning fully adjacent. They've exchanged all their topology information. Let's take a look at Palestra 1 and do the same command. Show IP OSPF Neighbor and check it out. He's full with both other routers. The reason he is full with both other routers is because one's a backup designated router and one is a designated router. So they will get his information. If it was a non-designated router, a drother, then what would happen is the state here would be two-way, meaning he knows that router is there, but he's not exchanging his routing table information. Since these are a backup designated router and a designated router, the state will be full here. But again, if it was a non-DR, a drother, then it would be a two-way state you would be seeing here if I threw a fourth router into this mix. Let's take a look at how we can change these things up by adjusting the priority. Maybe we'll up the priority on Palestra 1 and make it the designated router. I went into Palestra 1 and I changed the priority on the interface. If we go in and take a look, we can see that I used the command IP OSPF Priority 255. And OSPF is still running, same area. So if I do a show IP OSPF neighbors, nothing should have changed at this point. I'm still fully adjacent with both other routers, again, which I am because one's a DR and one's a BDR. Show IP OSPF interface will show me that I am not the designated router, even though I have a priority. The reason is because I haven't reset the OSPF process. Just because I go in and change a priority doesn't make all the routers go out and scramble around and do a new election. The only time elections take place is when a designated router goes down, the backup designated router becomes the designated router, and then a new backup designated router is elected. Just because you change a priority doesn't mean everything's going to go in and re-elect. So what you would do on the routers, if you wanted it to go through a new election process, you would clear the IP OSPF process using this command. What it would do is it would reset OSPF and go in and have it do a new election. Now on this simulator, no matter what I do, I cannot get this guy to become the designated router. So one of the little problems there with the simulators. I even got rid of OSPF, reconfigured it, set this priority first, and then turned on the other routers. It's still not going to happen. However, on an actual router, this priority, if I have this router up first and I set his priority to 255, he will become the designated router. And the command to reset the OSPF process to force an election is clear IP OSPF process. And the command to set the interface priority, again, is IP OSPF priority and then the number. So that's how I could manipulate what router actually became the designated router. So for a recap, let's go in and take a look at some commands here. Again, important commands: show IP OSPF interface. That command allows us to go in and view our designated router status. It shows us what's going on at our interface for backup designated router, or non-designated router. Will show us that information, as well as hello, dead interval, stuff like that for troubleshooting. Show IP OSPF neighbors goes in and shows us our neighbors and what state we're in. Again, we'll be in a full state with the DR and BDR, designated router and backup designated router. If it was a non-designated router, we would be in a two-way state, meaning we knew the other router was there, but we're not fully adjacent with that router because we're not sharing our information with them. We're sharing our information with the designated router. The backup designated router listens in, but he doesn't send anything back to us. If there is a particular router that I would like to be the designated router, maybe I like that router better, or it is simply a better router, or it's got less of a load on it, whatever the case may be, I can specify that with this IP OSPF priority, and then I've got a 0 through 255. If you specify the priority at 0, however, it cannot be a DR. Not equal to, there's a lot of slashes there. Not equal to DR. It won't be the designated router. And if I go in and set a priority of like 255, if I pick one router out, and this priority was 1 before, and that he's in that environment where a designated router is needed, everybody's at priority 1, and I change that, and I make his priority 255, they're not going to go in and do a new election. The only time a new election takes place if somebody takes that router out, the backup router becomes the designated router, so he will become the designated router, and then this guy, maybe throw another router in there, then this guy would become the backup designated router. And then if somebody takes that guy out, then he finally gets to become the designated router. That's the long way. Again, it's not recommended to use this command if the network's up and running, because everybody has to resynchronize, get all our information back. But if I wanted to, I could use the clear IP OSPF process, clear out their OSPF processes, and then when they came back up, this guy right here would become the new designated router, because I'd basically be forcing an election and they'd all have to exchange their topology information again and reset everything. So that's not recommended in an up and running environment. However, you can use this command to reset everything with OSPF. Again, just use it carefully. We have talked about OSPF and designated router, what a designated router is, when it's required. We've talked about how a designated router functions. Remember those multicast addresses, 224.0.0.5 and 224.0.0.6. This is the one, little smiley face there. This is the router again. This is the multicast address that everybody sends to the designated router with. That's what goes to the designated router. 224.0.0.5 is what comes from the designated router. Default settings there, how to specify a DR by changing the priority number, and some troubleshooting commands that you can use to check out to see your status, see what state you're in, and see which router is actually the designated router.